Okay, so in this lecture, we're going to talk just a little bit about induction, inductive arguments. So remember that an inductive argument is one that supports the conclusion, but that support is less than 100% guarantee that the conclusion is true. If it's the kind of argument that is intended to 100% guarantee that the conclusion is true, then that's a deductive argument. So induction and inductive arguments, or inductive logic, inductive reasoning, there's all these different ways you can say it. But the intention here is to support the conclusion, but not get it all the way to 100%. And it might be that it's just the sort of conclusion that it's impossible to give it 100% support. So we see this sort of thing in science and in statistics and those sorts of things. And so a wide variety of really common arguments that you see turn out to be inductive arguments. And with deductive arguments, the measurements were deductive validity and deductive soundness. To be deductive validity, to be deductively valid means that if the premises are true, then the conclusion is guaranteed, 100% guaranteed. Whereas here, instead we're talking about strength and cogency instead of instead of deductive validity and deductive soundness. We're talking about strength and cogency for inductive arguments. So strength being a strong argument, that's somewhat like being a deductively valid argument, but the conclusion, again, is not supported 100%. So the idea here is that in a strong argument, if the premises turn out to really be true, then the conclusion is supported, right? That the conclusion is probably true, but not necessarily true, not 100% guaranteed to be true. So we could say it's more likely to be true than to be false. We could say that it's at least now, given the truth of the premises, it's now more than 50% probable to be true. So it gives us some reason for thinking that it's true. You could say something like, if you were forced to bet one way or the other, you would bet on the conclusion being true. You might not be super confident, depending what these premises are, but nevertheless, you now have reason to suppose that the premise is true, or that the conclusion is more likely to be true than to be false. On the other hand, a weak argument, well, it doesn't do that, right? That even if the premises are true, then still the conclusion is not supported in any significant way. It doesn't give you any extra reason for believing that this premise, or that the conclusion is likely to be true. It doesn't bring it up over 50% likely to be true, or maybe it just has absolutely no effect on the probability of the conclusion at all. So let's look at a couple of examples. So, very simple example argument here. So most Canadians speak French. Bob is a Canadian, so therefore Bob speaks French. Like, well, it could be that Bob doesn't speak French. The first premise says that most Canadians, not all Canadians. So Bob could be in the minority of Canadians who doesn't speak French. Nevertheless, since we were told that most Canadians do speak French and that Bob is a Canadian, if you had to bet on this, it'd probably be smart to bet that Bob does in fact speak French. So even though the conclusion is not guaranteed, this is not a deductively valid argument. Nevertheless, these premises give you some reasons for believing that conclusion. On the other hand, here's a weak argument, right? So one that's not strong. So a small percentage of Canadians speak Greek. Bob is Canadian, so therefore Bob speaks Greek. Do these premises, even if they're true, do these premises give you any really good reason to bet on this conclusion? Like, probably not, right? The chances are still pretty good. It seems like greater than 50% probability that Bob does not speak Greek. So this is a very weak argument. On the other hand, we could talk about an inductive argument being cogent or uncogent. This is a little bit like when we were talking about deductive arguments. A deductive argument could be sound or unsound, but here we've got cogent or uncogent. So a cogent argument is one that's first strong and that all the premises actually are true. On the other hand, an uncogent argument is either not strong, right? It's a weak argument, or at least even if it's a strong argument, if one of the premises is false, then it's an uncogent argument as well. So again, let's look at some examples. Most Canadians speak French. Bob is a Canadian, so Bob speaks French. This is cogent because it's strong, and it's actually true. I don't know exactly what percentage of Canadians speak French, but it's a lot of them, right? And so it's true that most Canadians speak French. And so if Bob is a Canadian, then there's a pretty good chance that Bob speaks French. So I'm willing to bet on that conclusion. Doesn't guarantee that the conclusion is true, but it gives us good reasons for it. But then let's look at this one. Most Coloradans speak French. Bob is a Coloradan, so Bob speaks French. Well, this is a strong argument, technically speaking. If those premises are true, then they give you some pretty good reason for believing that the conclusion is true. But it turns out that that first premise is false. Again, I don't know exactly the percentage of Coloradans that speak French, but I'm pretty sure it's less than 50% of Coloradans speak French. So that first premise turns out to be false. Here's a few other kinds of inductive arguments that you might come across. I've got some examples of these ones here. And so even if these are very strong arguments, even very cogent arguments, they're the kinds of arguments that don't guarantee that their conclusion is 100% for sure true. So like a statistical kind of argument, as they call this, statistical syllogism, might look something like this. Here's a really simple one. So our limited polling shows that 52% of voters prefer candidate A over candidate B. So therefore, candidate A will win the election. Okay, well, that premise, the statistics that they gathered in that first premise, that gives you some reason for believing the conclusion, but it clearly doesn't guarantee it. And there can be lots of debate over the quality of that premise. Even if it's true that this is what the poll tells you, how much should we trust polls to tell us exactly what's going to happen in an actual election? What's the quality of this particular poll? Do they have flawed methodology or something? There's all kinds of ways that people might debate over the quality of this argument. So here's another one, argument from proper authority. So suppose some nutritional expert tells me that consuming vitamins will make you more healthy. So I consume vitamins, and so therefore I will be more healthy. Okay, so these premises give us some reasons for believing that conclusion. Maybe raise the probability of that conclusion being true, raises it above 50% probability. But this doesn't guarantee it. For one thing, I might have other lifestyle choices that make me unhealthy despite how many vitamins I'm eating. Plus, what is the real connection between vitamins and health? How good of an expert is this? How good of a nutritionist is this that's told us these things? So again, there's reasons for debating the quality of this argument. Inference to the best explanation is a real famous one, especially for, say, like crime scene investigation. So suppose it's something like this, some stereotypical CSI episode. They find some knife at the crime scene with this one person's blood on it. They also find that Bob's fingerprints are on the handle of the knife. And so therefore, we would conclude that Bob stabbed the victim. And so this gives us some pretty good reasons for believing this conclusion, but of course it's not 100% guaranteed. That's what makes some of these crime scene shows sort of interesting. There's all these weird twists and turns such that these premises could turn out to be true, but the conclusion could still be false, even though the premises do give us some good reasons for believing that that premise could very well be true. Argument from analogy is another real common one. So once you learn how to ride a bike, you never forget. It's sort of a standard cliche. And then we might say that driving a car is analogous to riding a bike. That is, it's similar in relevant ways. It's similar to riding a bike. So therefore, once you learn how to drive a car, you'll never forget. Okay, well, these premises give us some reasons for believing the conclusion, but we might debate, is driving a car similar enough to riding a bike, that the analogy holds, that what's true about riding a bike is also going to be true about driving a car. There's all sorts of different ways that you could sort of dispute this argument. So again, it gives you reasons for believing the conclusion, but doesn't guarantee it. So potentially a strong argument, potentially a cogent argument, but definitely not a deductively valid argument. Okay, so that was just a little sort of bit on inductive arguments, and I'll go ahead and stop there.